Okay, so we are actually going to do 9.5 today, okay? I am feeling very confident that I am not going to be here on Monday because I should be moving back into my house. So I'm planning on taking Monday off, possibly Tuesday, so that I can just be happy with that. So that being said, 9.4 is just another day of solving and word problems. I will make a video lesson. I know that's not everyone's favorite, but we all agree we're not going to whine about it. I'm doing the best I can, right? Okay, I think 9.5 is a little bit harder, so I would rather be able to teach that live, so that way I can get questions. 9.4 is really not that bad. But also remember, you've got review day too before your test. So like if you don't understand anything from Monday, we've got tutorials all week, and review day, we'll knock it out, okay? I know this says there's a homework check. I might just wait and check all the solving later, okay? Probably this day. But keep up with the homework because it will add up. There's a lot of problems, so I don't want you to get like too bogged down. And then we're going to throw a test review at you there. Just a reminder, the Unit 8 retest window is next week. I am going to be end of day Friday taking those tests down there. So if you are planning to retest Unit 8, you have to have turned in one of those retest tickets that I passed out last class. Does that everyone understand that? If you don't turn that in and I don't have it by tomorrow, you're not going to get a retest. Got it? Okay. And so I will get those there. It is in Testing Center is H110. Get there at the beginning of lunch. You'll have the entire hour. If you're going Thursday after school, like there's a separate box for Thursday after school than there is power lunch. So I will be putting those in the after school box if you selected that. So please let's try to do this right so it makes it easier. Okay? So I have tutorials tomorrow if you need to go over your Unit 8 test. That's kind of your last time if I'm out. So there's that. Test is coming up. We're moving on. Okay? And again, homework check will probably end up being on review day. I'll clean up Canvas later today. Okay, so we are on page 19. Everyone with me, page 19, 9.5. We're going to go over just some more solving problems, and then we're going to go over the word problems. There's only one type of word problems, but they are a little bit more complex, so I wanted to teach that live. But let's just start with how to solve algebraically, because remember, this is its own test topic too, is how to solve algebraically. So last class, the algebraic problems that we started with, I think we ended with some that were not proportional. But when we had a lot of our word problems set up to where it was one fraction equal to one fraction, so we were just cross multiplying. Some of our motion problems will be like that as far as solving with cross multiplying, but some of them are not. And next classes are also not. So we need to know what to do here. So remember, when we're solving, we have to still find an LCD. And our goal is to get everything over that LCD, all sides of the equation. But we also have to consider our domain restrictions, what x cannot be, okay? So these types of problems, again, they're a little bit more going on. I want to try to factor whatever I can. Can I factor anything in the first fraction? Anything in the second? Anything in the third? Yes, the denominator. How does it factor? X minus 4, x minus 3. Very good. So do that first. You still want to check one fraction at a time. If anything can simplify, I think that'll happen on one of them. It'll make life easier, but nothing can simplify here. So what is our LCD? X minus 4. That checks this one and this one because they're separate fractions and they share it. And what else? X minus 3. It's also pretty common that if you have to factor a denominator, that one or both of those factors will match somewhere else, okay? Because a lot of times you end up being able to share there. So now we have to account for our domain restrictions, which mean we take all the things in our LCD, all of our denominators, and set them not equal to 0. X minus 4 cannot equal 0. So what can x not equal? 4. X minus 3 cannot equal 0, so x cannot equal 3. You don't have to write the first one. You can go straight to the actual restrictions, but these are the two things that x cannot be. Oh, okay, I noticed this in 4th period last class. So for you guys, flip back real quick to page 10, problem 2. I didn't catch this until I was teaching 4th period, so my bad on that. But problem 2 on page 10, it was a solving. It worked out to where when we factored out that second fraction, we had a common factor right here of x plus 1. Do you remember this now? Okay, technically, that x plus 1, it does drop out, so it's not a part of your LCD. But because x plus 1 is a factor in the denominator, it is still technically a domain restriction. So x also couldn't equal negative 1. Because it's a common factor, it's a different thing graphically. It didn't mess with our work or anything, but I just wanted to clarify that. Even if you have something that, like I said, simplifies out, if it is a denominator like at all, it has to be considered a restriction. So just wanted to go back and fix that. My bad. Okay, back to page 10. Or page 19. Okay, so here's our LCD, here's our domain restrictions. Now I'm good to start fixing the numerators. So when I look at my first denominator, it only has the x minus 3, so what do I need to multiply the numerator of 3 by? What? It has x minus 3. What does it need? X minus 4. Plus 4. This one has the x minus 4. What does it need? What? Do you know the answer and you're working it, or are we lost and don't know what I'm saying? Because normally y'all answer. This needs an x minus 3. Okay, equals, what does 25 need to multiply by? Anything? Why not? Because it has both of them. Now, when we're solving, do I have to put the LCD on the bottom? When we're solving? No, because it doesn't matter. If they're the same on the denominator, then the numerators have to be equal. So I'm okay if you just don't, you gotta use it, and you gotta multiply by what you're missing, but you don't have to actually write it down. Simplifying's a different story. Solving, you don't need it. So let's clean this up. So this will give us 3x minus 12, just distributing, plus 4x minus 12 equals 25. Okay, combine like terms. 7x minus 24 equals 25. Out of 25, 7x equals 49. Divide by 7, x equals 7. Make sure y'all check. Go back and check your domain restrictions. Is there anything wrong with 7? So is 7 a valid solution? Yay. Go math. Okay. All right, let's look at number 2. X over x minus 3, can we factor that at all? Anything? No. Minus 7 over x plus 5, can that factor at all? No. 48 over 2x squared plus 4x minus, oh, typo. This is supposed to say a 30. I don't know why. Did it not factor? Makes sense. It's supposed to be a 30. Okay, so let's factor this. What's the first thing to factor this? How's a GCF? What's a GCF? 2. X squared plus 2x minus 15. Okay, that GCF's nice because it makes it easy factoring now, right? So this becomes 2 times 2 numbers that multiply to be negative 15 add to be positive 2. Plus 5 minus 3. Y'all are kind of freaking me out because you're so quiet today. Are we okay? Yeah. Sort of. Okay, so I did say that it is good practice to, I'm going to kind of rewrite this. I'm going to rewrite this actually. The whole thing real quick, because there is something we can do here that if you don't do it, it's not detrimental. But again, I want you to get in the habit of checking for it when it is okay. So this is really 48 over 2 times x plus 5 times x minus 3. Okay, so again, if you don't notice this, you can still get the problem right. But given the fact that this portion of the test, like solving when it's already set up for you, is non-calculator, I would do everything in my power to make life easier, okay? So as far as simplifying goes here, there's not any common factors that we can simplify. One fraction at a time is what I'm checking. But what do y'all notice about this right here? Can I simplify that? Okay, why is that safe to simplify? When is the only time it's safe to simplify? When it's a product over a product. It's kind of like work within one fraction at a time. So I could, in fact, write this as x over x minus 3 minus 7 over x plus 5 equals 48 over 2 is 24 over x plus 5, x minus 3. What I also think is easier about that is now you don't have to account for that 2 in your LCD. Up here, before simplifying, you would have to have a factor of 2 in your common denominator, okay? But now that I simplified it out, I don't have to. So what is my LCD going from here? X plus 5, check, check, and x minus 3, check, check. So what are my domain restrictions? Again, those come from the denominators. What can x not equal? Two numbers. What can x not equal? -5. X cannot equal +3. Okay? And then go through and multiply by what you are missing. So x times... You don't get this? Okay, can you ask me a question that maybe I could help actually answer something? Because I don't get this, I don't really know how to help with that. Which part? Okay. Still doesn't help me help you. Think about what part, and I'm going to keep working. X squared plus 5x minus 7x plus 21 equals 24. Okay, the second you start getting x squareds into things, what is your brain telling you to do? Set it equal to what? 0. Factor. Keep the squared term positive. So this will be x squared. 5x minus 7x is negative 2x. Subtract the 24 over. This is negative 3. Is this easy factoring? Yes, because a is 1. Did I do math wrong? Okay. What are two numbers that multiply to be negative 3 and add to be negative 2? Negative 3, positive 1. Okay. So what do those actually give me as possible solutions? X equals 3 and x equals negative 1. Okay. Do they both work?
No.
Which one doesn't? X equals 3. Why does 3 not work? It's a domain restriction. What would happen if you plugged a 3 back in? You would get a 0 where? In the denominator. Zeros in the denominator. Those are your problems. Okay? Real quick. What if you... Okay, let's go back to before we did this reducing thing right here. I just want to cover this too because I don't think we talked about it in y'all's class because you know the first class, sometimes questions come up in my other classes and they make me think. Okay, let's go back to before we reduce the 48 over 2. Just for a second, we're going to go back to hypothetical land. Okay, listen to what I'm saying. If you had a 2 down there, like I said, it would have to account for your LCD. So let's say you had an LCD that did have a factor of 2, or a factor of 12, or 4, or whatever, just a plain number. If you have a factor that is just a plain number, does that cause a domain restriction? No. What are the only ways that you can have domain restrictions? Is factors with what? X's, okay? So don't just, sometimes people will see and there's problems, I know, we've worked. Maybe they're in the notes, maybe they're in the homework, but you have an LCD that has a factor of 4 and people will go and be like, oh, X can't be 4. No, it only has to do with factors that involve X. So it's going to be the opposite of whatever that is there. What if your factor had an X in it? It was like a 4X. What is that domain restriction going to be? X can't equal 0. Just like if 4x, if you were solving a quadratic, that would give you a root at 0. So if there is an x in it, then that means it is resulting in one of those restrictions. Okay? All right. 3. 3 and 4, these are good. Oh, this one looks like fun. This is my favorite factoring pattern. My favorite. There's another typo. Oh my gosh, what the heck? Sorry, I'm just seeing these because I didn't. No, it's supposed to be a 2x minus 10 on the top. Because we're trying to make something cool happen here. Okay, all I'm going to do with 1 is write it as 1 over 1. And if you don't have to put over 1, like, because you got it, then cool. 2x minus 10. How can I factor that? I'm going to rewrite it. 1 over 1 plus, what can you do with 2x minus 10 once you fix that? Because I don't know why there's a typo. 2 times x minus 5? Okay. Over x squared minus 10x plus 25. What is that? X minus 5. X minus 5. Very good. Okay. Whoa, seeing something here. Seeing something here. On the other side, can I factor 3x plus 5 at all? Because for some reason, they're not there. I'm looking at my answer key, and it's like, oh, this is supposed to be written in. We're going to blame Google Docs. It's probably their fault. I don't know. What about x squared minus 25? What is that called? And that is my favorite. Okay? Recognize that. That's going to be all over the place. GCFs, difference of squares, that's easy factoring. You don't have to number puzzle. You don't have to do any of that, so it's helpful. All right, what happens here? In the middle. On that middle fraction. It's safe to do this. Why? Why is it safe to do that? Because it's within the same fraction. It's a product over a product. If you don't do it, you could still get the problem right, but it's just going to get a little bit messier. Okay? So I can simplify that there. So let's rewrite it one more time. I got 1 over 1 plus 2 over x minus 5. There's still an x minus 5 left, but at least it looks better. Equals 3x plus 5 over x plus 5, x minus 5. All right, we need our LCD. X plus 5, check. X minus 5, check, check. Okay, and then we don't have to put the 1, factor of 1, because it's just a 1. But if it was something else, we would. If it was any other number other than positive 1, we would have to account for it. What's your domain restrictions? You can write that as like plus or minus 5, like that. You can write it one time, since it's the same number. And one's positive, one's negative. Or you can separate it out, whatever's fine. Okay? So what do you have to multiply the 1 by? This one has a denominator of 1, so you have to multiply that by the whole LCD. X plus 5, x minus 5. Plus, what do you have to multiply the 2 by? X plus 5. Do you have to multiply the 3x plus 5 by anything? No. It's really nice when that happens. Okay, because sometimes it can just make a lot of foiling and multiplication and all the things. So at this point, and again, our denominators don't matter because it's a solving. We've got them all over the same denominator, so it's really just the numerators that we're working here. Okay?
Why do the 2 times x plus 5?
Because this is only over 1 of the factors of my LCD, so I had to convert it there. Okay? Now it's just algebra.
This one is so confusing.
What are you talking about?
It's just like throwing me off.
But x plus 5, x minus 5, I mean, at least it's pretty easy. It's just x squared minus 25 plus 2x plus 10. Anytime you get an x squared, we're setting equal to 0, and we're factoring. We're putting it in standard form. I'll take a couple steps to do it just so that way we don't get lost. This will be x squared plus 2x minus 15 x squared minus x minus 20. So when we get it all equal to 0. I took a few steps to get there. If you do less steps, that's okay. Is it easy factoring? Is it my definition of easy factoring? Yes. As my definition of easy factoring has been since October, it's when the a value is 1. Two numbers that multiply to be negative 20 and add to be negative 1. Negative 5, positive 4. Okay, so anytime you have an x squared, you're potentially getting two solutions. Okay? So these solutions, they may not be valid, but the solutions they would give me are positive 5 and negative 4. But then I got to go back and I got to check my restrictions. Are both of these okay? Which one is not? 5 is not okay. So what's my one and only solution? X equals negative 4. Okay? Do not forget to go back and check the domain restrictions. Okay? Because some of y'all did that on that last test when we had extraneous solutions. You just left it off. And that was disappointing. I don't think there's any numbers missing here, but this one's fun. Okay. Factor. This is supposed to be an x to the third plus 3x minus 9. So can we factor this one at all right now, this numerator? X to the third. That's not a typo. I can't do anything with that. What about the denominator? X squared minus 3x. Can take out an x. Very good. Minus, can't do anything with x plus 6 over x minus 3 equals 3 over x. Can't do anything with that. Okay, this is good. This factoring that we've been doing on all these is really good practice for the multiplying and dividing stuff too, because we're going to throw all that at you. GCFs, difference of squares, easy factoring, hard factoring, all the above. Okay? All right, so what's our LCD? X, check, and x minus 3. There is another factor of x, but you only have to write it once because they share. Okay? So since this guy is an x, even though it's not a binomial, that's going to give us a domain restriction where x can't equal 0. Please don't miss that. What's the other one x can't equal? 3. You can also write them commas like this, like I did on this one. You don't have to write x can't equal every single time, showing you some options there. Okay? Are we missing anything in the first numerator? No, so that's not going to change. I would put parentheses around this x plus 6 right here, so you got to be careful about that. What does that need to multiply by? That needs to multiply by x. I'm going to put the x first, like that, because x is a monomial. It's just one term. So as far as distributing, because I will need to distribute that. And you could think of it as a negative x. Are y'all okay with that?
Is it meant to be x cubed?
Yes. And then what does the 3 have to multiply by?
X minus 3.
It is. It's supposed to be it. Yes. You'll see why here in a minute. Okay? Is everyone okay with this middle piece, though, the way that I wrote it? We still good? So when you think about that, you're distributing a negative x, so just be careful. So this is x to the third plus 3x minus 9 minus x squared minus 6x 3x minus 9. Y'all checking? Okay, again. I'm thinking I need to set this equal to 0, move stuff over. I'm also going to reorder it, so I'm going from the highest exponent. So x to the third doesn't have anything to combine with. I'm going to put my minus x squared next. It doesn't have anything to combine with. Here I've got a 3x and a negative 6x. That is what? Negative 3x, but then I'm subtracting a negative 3x. Are we okay if I do that in one step? What happens with your 9s?
cancel out.
So it's like this 3x and this 3x are going to zero out. This minus 9 are going to zero out. And then I'm left with that.
Can we take an X out today?
Yes, we can. So that's why this is not a typo. If you were factoring this, you would start by taking out an x. And then it's x squared minus x minus 6. Then it's x times two numbers. What are they? Multiply to be negative 6, add to be negative 1. Negative 3, positive 2. So how many potential solutions are we going to solve for? Here, y3. There are 3 x's. Okay, so this is going to give us that x could equal 0, x could equal 3, or x could equal negative 2. That comes from here, and from here. But check them with your restrictions. How many of those are going to work? Only one of them. That's a restriction. That's a restriction. Your solution is x equals negative 2. And that's because of those. Okay? All arrows everywhere. So, that is, I think that's the last, already set up solving one in this section. I honestly think the ones that are set up in 9.4, which I'm going to have a video for, I think those are even a little bit easier. Because we kind of meant for the third day to be the hardest. So really, those will be okay. Yeah.
How is this any different from what we did?
It's not different. The only thing is that these problems we had, you had to factor in the denominator more than we did last class. Last class they were mostly already set up to be just binomials already.
In practice, we kind of had to do that.
Did you really?
Yeah.
Oh, well then it's not that different. It should be easy. With this though, I think this one was kind of cool because you had some stuff that could simplify out, making it a little bit easier, that sort of thing. Okay? All right, are y'all ready for our motion problems?
No.
Well, you better get ready. Because first of all, I'm not going to go in order that they are because that wouldn't be fun. We're actually going to start with number 7. Okay? So here's your real world application for today, guys. Math in the real world, okay? We need to know if Taylor Swift is going to be able to make it from Tokyo to Vegas for the Super Bowl. Considering time change, tailwinds, headwinds, all the things, we need to know how fast she needs to fly her private jet, okay? So she can make it to the boyfriend's Super Bowl. So math in the real world, okay? Right now. This is what we're doing. Motion problems. So don't ever say you can't use this stuff because all of you Swifties need to get to calculating on that, okay? Because we need to know if she can make it. Let's actually start on number 7. These problems are labeled motion problems. Lots of people want to know. Lots of people want to know about Taylor Swift. Did you just say no one wants to know? Oh. You like what?
That's my favorite song when I was 5.
Of course. That's a good one. Okay, so motion problems. Since we're starting on number 7, because I'm going out of order, here's the formula. Did she write it? Okay, she wrote it on the other page, but I'm just going to start with it. Distance equals rate times time. Okay, that's kind of your setup for these. It's actually not, we're going to be talking more, the types of problems are going to need to be solved for time. So I'm actually going to draw an arrow right here. How would you solve that equation for time? Time equals distance over rate. Okay, so this is really kind of what we're going to use here. We're going to be talking about time. We're going to be talking about moving, cars, trains, planes, boats, all the things, okay? And some of these are not that bad. There's one type of problem that you kind of got to be careful with, and that's the one that people don't like, but we'll get there. Okay? There's also 2 kinds of setups for these. There are problems that they're going to give you a total time problem or a same time problem, okay? Same time is easier because it's a proportion. Total time is not. So we're going to do a little bit of each. So let's start with the first one. We're going to just progressively get more complex. So Joey's making a trip with a friend. He travels 200 miles to Sam's house at an unknown speed. Then he and Sam travel 300 more miles, going 25 miles per hour faster in the same amount of time. I'm circling that it took Joey to get to Sam's. How fast were they going on the second part of the trip? Okay. We have to know how to set this up, or else there is a 0% chance we're going to get the answer right, okay? So, we get to use a calculator. So the first thing that I would do is when you recognize the motion problem, again, it's planes, trains, cars, bikes, boats, like anything moving distance, that type of thing. You need to figure out, is it same time or total time? So since this says same amount of time, I'm going to be writing time for trip 1, so I'm going to call it T1, is equal to the time for trip 2, okay? And then I'm going to even go and sub in what time is equal to. Well, time is a distance for trip 1 over the rate for trip 1. And I know because it's the same time, that's going to equal the distance for trip 2 over the rate for trip 2. Okay, this is just my thinking, okay? Same time, which means it will be a proportion, which means we get to cross multiply. We like doing that. It's easier. No LCDs. You don't have to worry about that. Okay, so let's talk about trip number 1. What is the distance that he's going on trip 1 to Sam's house? What does it say? 200. So 200 is my distance for trip 1. Okay, going to Sam's. He's traveling at an unknown speed. So do we know the rate? What should we call it? X. We don't know. That's the unknown speed. We don't know his rate. But we know that that's going to be equal to what's the distance that he and Sam drove together on the second half? 300 more miles. So 300 is the distance for trip 2. But what do you know about their rate?
Plus 25.
25 miles per hour faster. So the trip by himself, he's going 25 miles per hour faster. So I have to add 25 to that. Okay? That's your setup. That's all you have to do for setup. It's a proportion, so to solve it, we're just going to cross multiply. That's not that bad, is it? Not that bad. So we have, and you have a calculator for this portion of the test. So we have 200 times x plus 25 is equal to 300 times x. So we solve for x. Now, with these, it's really important for you to pay attention to what x represents. X was the rate of which trip? The speed, whatever, of the first one. So this is the speed of trip 1. What's the question asking for?
Trip 2.
Second part of the trip. So are you going to put 50 as your answer? No. So how fast are they going for the second trip? Second trip is what you're looking for. Okay, so this is your speed of trip 2. So you would say 50 plus 25, 75 miles per hour on trip 2. That would be your actual answer to the problem. So just make sure, again, you're answering it. Because I could ask you for both. I could ask you for one. Yeah.
Do you have to write on trip 2?
75
miles per hour.
I mean, if you're answering the question, it might help you catch it, too, if you realize that's what I'm actually asking for. But I practice putting units and stuff, because there's going to be stuff in AP Pre-Cal that they will count off if you don't do the units and you don't do them right. Okay? So we need to practice with that. Okay? But that's our answer. Are we cool with that? Yeah? Okay, look at number 8. I think you can do number 8. Ready, set, go. Okay, there's a couple different ways you can set this up depending on how you read the problem. But ultimately, we need to know that it is talking about two different types of trains. Okay, Amtrak and Central. It does say that they can travel however far in the same amount of time. So this is a same time. So I put time for the Amtrak is time at the Central. Then I put the formula in. Again, you can go straight to the formula or not. I don't care. I would just say try to stay organized. So the distance of the Amtrak passenger train was 400. The distance of the freight train, Central freight train, was 330. So those are my numerators. Now, I set it up as the Amtrak is going 14 miles per hour faster, so I did X plus 14 as my rate for Amtrak, and then just X for Central. However, some people do like the Central is X minus 14. I mean, you can kind of decide how you want to do that there. But either way, it's a proportion, so you get to cross multiply. It is asking for the speed of each train, so I figure out what you'll find X. Figure out which train that goes with, and then find the other one, okay? Because it is asking for both. So that's how you solve that. And if you're done, then take a little brain. Did y'all get 80 and 66?
Yes, it is.
Yes. So again, they're not that bad to solve. The numbers do get big. You will have a calculator on this portion. But again, you really got to go through and you got to recognize, hey, this is a motion problem because we're talking about moving, we're talking about distance, speeds, that type of thing. Stay organized, okay? Know what your variables are talking about. Know what, I do think it is worth kind of doing some labels here so you know what's going on, all right? And then, and you have to think about, too, someone asked, again, sometimes I just get good questions after y'all's class. With the word problems, we're solving, so I didn't write my restricted values down, my domain restrictions on any of these word problems here, because there's more than just where the denominator is 0. Obviously, that's a problem, so we should consider it. But it's more about, like I said it in 4th period yesterday, so I think it's more about, understanding the reasonableness of, what you're talking about. So if we're solving for, speeds, we can't have negatives. That doesn't make sense, okay? So we would, if we get a negative, and we're about to have one that we do, I think, maybe not, maybe it's on something else, we would have to throw that out because that doesn't make sense in terms of the story. And then the restrictions here, your domain restrictions would be negative 14. Well, that we already said we can't have negative speed. Or 0. Okay, well, that also doesn't really make that much sense. So do you have to write them separately like you do on the algebraic ones? No, but do you have to kind of watch out for them? Yeah. Okay. Okay, let's do number 9. And then we're going to go back and we're going to do the first two because those are the ones that everyone hates. Now, this problem is not much trickier to set up, but it is a little bit more involved in solving because it's not a same time problem, okay? So this is kind of Taylor Swift style here, okay? Plane flies 1,000 miles from New York to Chicago at a speed of 580 miles per hour. It's telling me this is a motion problem because you're going to have it all jumbled up on your test. On the return trip, a tailwind helps the plane move faster. Okay, so that is a factor that's affecting the speed of the plane. It's aiding the plane moving. The total flying time, circle that phrase. I'm not going to answer your questions if you're confused while I'm talking. The total flying time for the trip is 3.4 hours. So here's what makes the total time problem not as fun. It's not time equals time. Total times are set up like this. Time of the first trip plus, time of the second trip is equal to time total. It is the same distance, but that's not the setup. It is the same distance. You are correct. You will have the same numerators. Don't shake your head at me. That's rude. Okay? So when I take it back to I'm representing time as distance over rate. So I have the distance of the first trip over the rate of the first trip plus distance of the second trip over rate of the second trip is going to be equal to, now I know what the total time is. I don't have to write that as a distance over time. What is the total time? is going to be equal to 3.4. And there's a decimal, so we can already tell we don't love that. I will tell you, these numbers get big. But we got a calculator. That'll be fine. It's all going to be fine. Okay, so it's fraction plus fraction equals, you should know what the total time is. So this should be a number right there. Okay, as Matthew pointed out, the distance is the same because you're going somewhere and you're coming back. So what is our distance? 1,000. So my numerators are both going to be 1,000. That is true. We're equal to 3.4 right here. Now, the rates are going to be a little bit different though. So on trip 1, what's the speed that the plane's going? 580. And there's no other, it doesn't tell us that there's any sort of like factor on that. So they're just going, we're just assuming that they're going that way. But on the way back, they have a tailwind. Okay? So they're going to increase their speed or decrease? With a tailwind, think wind at your back. That's helping. A wind at your back is helping you. So you're going to add, it also does say it helps them move faster. Thank you. 580 plus x. Something that would make you move slower, that would be called a headwind.
So if it was slower, would you do minus x?
If it was, yes. Okay? So we have the speed plus that extra factor. Okay? Speed plus the factor. And if it said headwind and it was going against you, you would do a minus. But this is going with us, it's making things go a little bit faster. Okay? And so now we have to solve this. So the solving of this is more involved. Because is it a fraction equals a fraction? Is it a fraction equals a fraction? No, it's not. So what are we going to have to get?
LCD.
We're going to have to get LCDs. This is not the only way to do this problem. This is not the only way to do this problem, but this is the way I'm going to do the problem because of the other setups we'll do. So what is our LCD going to be? 580. Check. And what else? Okay, hold on. Are 580 and 580 plus x different? Y'all need to recognize that those are two different factors. 580 and 580 plus x are two different things. They do not share the 580. They're not the same. Okay? So, what are we multiplying 1,000 by? It's got the 580. We got to multiply it by 580 plus x. The other 1,000 we're multiplying by just 580. What's the 3.4 multiplying by? Both.
Yeah, both. Oh,
Yep.
Okay.
We haven't really done one like this yet, but it's possible. If you just got like a whole number on the other side, you have to multiply it by all the LCD. So it's getting kind of yucky, but it's all good.
Oh my god.
Yeah. This is why you have a calculator. I don't even want to try to do this without. All right, so we got to distribute here. And this is going to give us 580,000 plus 1,000 x plus I'm going to do the 3.4 times 580 first. 4 times 580. That's 1972.
Wait, why did you get 1972?
I multiplied 3.4 and 580 first. Because you have to account for that 3.4. It has to multiply by both parts of your LCD. So I just did that, and then now I'm going to distribute this here. And I'm going to combine. I'm just kind of doing it piece by piece. Okay, so this will be 116,000. Yeah, I got a decimal too. Plus 1,000 x. 1972 times 580. 1143,760. We're going to do, for now, we're going to do 2 decimal places. If that subject should change, I will make sure before your test, like, that it says it on there, or it's not confusing. But this is speed. Or no, actually, what are we finding? We're finding the tailwind, okay? So it's the speed of a wind. It can be a decimal. I know the numbers are yucky, but it's okay. We're just working. Anyone confused? Anyone getting different numbers than me so far? We're good? I'm going to write what I'm doing so that way if you are lost, this is what I'm doing. I'm going to subtract this. 1, 1, 4, 3, 7, 6, 0. Isn't it nice of us to give you a calculator for this test? What if we didn't? That would be terrible. I don't think I would be able to do this problem. This is...
I don't think I put enough zeros.
Oh. 162. 40. That's what I got last year. Yay, yay, yay. All right, 16 point. We'll say round to the hundreds. We'll say that for now. I'll let you know if that's a problem.
So what did I get 13?
Why'd you get 13?
I don't know.
Look at that again.
1.
So, what did we solve for? What did we solve for?
Wait.
No.
What?
Tailwind.
I don't.
Tailwind. Tailwind is 16.71 miles per hour.
I don't think I put enough zeros.
It might be something like that if you didn't put enough zeros. Now 2 problems. These are motion problems. We are still living in the same time versus total time. Okay? We're still in that world. However, these types of problems, they're motion. They have to do with, like I said, planes, trains, automobiles. It's kind of similar to the tailwind thing. But these problems are about being in water. Okay? And so when we're in a river, we're in the rivers, because we've got currents that we have to consider. Okay? These are the problems that on this test everyone is always freaking out about. And like I said, if you listen to what I'm going to tell you and you write down a couple of things that I do to help with your setup, these don't have to be that hard. Okay? Do you trust me?
Yes.
You should trust me. I've taught this class a long time. We're going to start with number 5. Okay? You've got a paddle boat. Paddle boat can move at a speed of 2 kilometers per hour in still water. So you know the paddle boat speed. Yay. The boat is paddled 4 kilometers downstream in a river in the same time, I'm circling, it takes to go 1 kilometer upstream. What is the speed of the river? So first thing I want to write down is not anything different from the other problems. When it says same time, I'm going to write time equals time. Okay? First they're talking about going downstream. Then they're talking about going upstream. Okay? How do we write time? As a distance downstream over rate downstream is equal to distance upstream over rate upstream. So same exact thing so far. Okay? The distance part we can fill in pretty easy. How far is he going distance-wise downstream? 4. So 4 is going to be the numerator. Distance upstream is 1. Okay? Does that make sense that going downstream you can go further, faster than going upstream, right? Okay, keep that in mind. Here is the phrase that when, not if, when you see a problem that has to do with currents or tailwinds or headwinds or something like that, I want you to write this little phrase down right here. It's for your rate. Boat speed plus or minus current. Okay, if it's a river, you're going to be talking about some sort of apparatus in the water. That would be the boat. Or you. Sometimes I write it your speed plus or minus current. And the current acts the same way that the headwind, the tailwind, that would act, okay? So here's where this gets a little bit confusing is sometimes I give you the boat speed and you're finding the current. So your variable is over here. Sometimes it's the reverse. So if you write this little phrase down and then you go back and you read the problem, it's going to tell you where your variable is and where your number is. So let's see what we have. The paddle boat can move at a speed. So what do we know? Do we know boat speed or do we know the current? We know the boat speed. What is the boat speed in this problem? 2, plus or minus. We don't know the current. What is the question asking? What is the speed of the river? That is the current. So in this problem, my rate is either going to be 2 plus x or 2 minus x. That is the tricky part. But if you write this down, and I'm not kidding, those of you that don't write it down and get the problem wrong, I'm going to laugh at you while I grade your test. Because you should have written this down. Okay? It makes it very easy. Now, let's think logical here. If we are going downstream and we can go further, do we need to use 2 plus or 2 minus? We're using plus, okay, because we're going with the current, okay? Our little boat and the current's pushing us faster. That's why we go further. If we're going upstream, we are working against the current. So you kind of already did the 2 plus, like on that last problem when y'all added the tailwind in. We just didn't have a headwind that the problem told us, so we didn't have to consider it there. But it's always like you are going faster, okay? And then there's that added factor, wind, current, whatever. Now, can we cross multiply this? Yes, we can, because it's a proportion. Ready, set, go. It's not terrible to solve. And with this, since you do have a calculator and it's speed, this is, I don't know, I kind of prefer decimals with these types of problems because they're talking about rates and stuff. If you gave me a fraction, I wouldn't count that wrong. But this is going to give us that x is, I got 1.2. Is that what y'all got? 6 over 5 is fine. That's fine too. Okay. So what did I find? What did x represent here? So the speed of the river or the current, whatever, is 1.2, and our units on this problem are kilometer per hour. And that's, again, written in the problem. Okay? So, again, these total times are easy because they're proportions. I just said that backwards. The same times are easy because they're proportions. It's the total times, number 6, that get a little bit trickier because of the LCD and stuff. But the thing that just kills me on this problem, like people can do the driving questions over and over and over again and they don't get the rates wrong, but it's when you have this added factor, like I said, a current, a wind, anything like that, you just got to know. It's you in the apparatus, whatever that is, boat, train, plane, anything, and then the added factor or possibly subtracted if you're going against it. Yes?
So why don't we have to do that for the tailwind problem?
So we did do it for the tailwind problem because they told us the tailwind was in addition on the way back. So the plane speed, our speed was 580 plus the tailwind. This problem did not say anything about a headwind. So if it would have said that you were flying into the wind on the way here, we would have needed to put 580 minus x. But it didn't say that. So I guess we just assumed there's no wind that day. I don't know. But so we did it. It made a little more sense with that problem because you only kind of had to think about it one time. And it's logical that if you have wind at your back, you're going faster. But it's this problem that you have it on both. Okay? Okay, so let's look at number 6 real quick. This will be a final problem I do with you. You're going to get the rest of the class to do homework, which is not going to be too much time, but a little bit. At least try to get your word problems set up. The speed of the current in a body of water is 1 mile per hour. One swims 2 miles against the current and 2 miles with the current in a total time of 8 third hours. Okay. So it's not same time, which means now I know my algebra is going to be a little bit worse here, but it's not anything I can't handle. So total time is like this. Time, which way does it say he goes? He says he goes against the current first. So is that, if you're going against, is that upstream or downstream? That's upstream. Plus the time he swims with the current equals my total time. Time total. I'm talking distance upstream over rate upstream plus distance downstream for rate downstream equals, what is my total time? 8 over 3. All right, what's my little phrase that I need to write? Because we've got a factor on our speed. Rate is boat speed plus or minus current. Write that down so you know where the variable goes. Okay. You can write human speed plus or minus current. That's fine. It's fine. You can correct it. You can write Juan's speed plus or minus current if you want to. Okay? So what do we know? This problem tells us, the first sentence, the speed of the current is 1. So where am I going to put the 1? Am I going to put that for Juan's speed? No, I'm going to put 1 for the current. I'm just filling in my little chart. We're trying to find how fast he can swim. So where's our variable this time? In the front. And this is what people mix up. You've got to make sure you get the variable in the right place. It does matter. It doesn't matter with addition, but it does matter with subtraction. So write this down and fill it in. Okay? All right, what is the distance? It's a total time, so your distance is going to be the same. How far is he going and then coming back? 2 miles. So 2 over something. 2 over something equals 8/3. Now let's think about the somethings. These are the rates. Upstream is going against. So we're going to use the minus. Downstream, we're going with. So we use the plus. But if you write these backwards, these denominators backwards, it's going to be wrong. So you got to be really, really careful here. Now, this is not a proportion. Thus, the algebra is about to be worse. What is your LCD? 3. Good. X minus 1 and X plus 1. Check, check. Okay? So, reasonable values, this is speed. Is anything negative going to make sense? No. Okay? And then the only other restrictions would be +1 wouldn't work with that, but you're not going to get that. Okay, so what are you missing? What does the first 2 have to be multiplied by? X plus 1 and what else? 3. So do y'all want to go ahead and just do that as 6? Or I should probably write this both. X plus 1. The other 2 has to multiply by 3 and then the 8 has to multiply by just the factors. Okay, then we've got 6x plus 6. So I get an x squared. I'm thinking, bless you, set this equal to 0. Keep your squared term positive. I'm going to go ahead and combine like terms before I start moving stuff. Oh, that's nice. That goes away. Oh, this actually is not that bad. So then I'm going to go over here because I'm running out of space. So I would have 0 equals. I want to keep that 8x squared positive by all means. Did y'all know with 8x squared minus 12x minus 8? could also use just like manners, like please. I can slow down. Please slow down. Okay. Do we have a GCF here?
Yeah,
It's not 8. Ugh. It's 4. This will be 2x squared minus 6x minus... Oh my gosh, that's not 6. What is that? 3. Is this easy factoring? Does anyone want to do this factoring? No. I don't want to do it. We have to. Do you want me to tell you?
Yeah.
Ends up being 2x plus 1 and x minus 2. Okay, how would you do that factoring if this happened to you on your test? Tell me, words, what would we do? We would group it because the a value isn't 1, but we've had enough today, so I'm okay telling y'all that that's what it is, but I reserve the right to put that on your test, okay? And you need to know how to do it. So what possible solutions could this give you? 2x plus 1 would give you x equals negative 1/2. It's a speed. Is that possible?
No.
Okay. X minus 2 would give you x equals 2. Is that reasonable for a swimming speed? So we would say, yeah, speed can't be negative.
Why did you get the 4? Just like not.
The 4, since there's no variable with it, doesn't affect your solutions at all.
Okay.
It's just a vertical stretch. If there was an x, then it would be a 0. If it was a 4x, it would be a 0.
Okay.
But so we would say he swims
So there's only 2.
swims at, what's the unit? Miles per hour? 2 miles per hour. I feel like that's actually kind of, I don't know. How fast do people swim? I don't know the answer to that. Okay, so at this point, you have 9.5 homework. Get working on that. I will have a video for 9.4 lesson. Learn it. It's not, the word problems are not crazy, okay? There's also a little more solving. I'll have a video over that. I'm going to move the homework check to review day. So all the final 3 solvings are going to be on review day, plus your review. So don't mess up.